Hello everyone, welcome back to another live stream. Today we are going to be going over the Ferrari 488. Okay, and essentially what I'm doing, as with most of the time when it comes to reverse engineering, I am going to be working on the multi-mapping functionality. So working on the multi-map for the Ferrari 488, and we're going to be using a combination of ASAP2 demo, which allows us to view the ASAM standard file of the Ferrari and go through all the different measurements, calibration, variables and characteristics within the file, which will allow us to link our functions, write our code and inject it where we want it, and sort of understand the structure of how that works. Another thing that we're using is WinOLS. So with WinOLS, of course, it essentially is a very complex and sophisticated binary editor, which is tailored towards the modification and calibration of like program code for engine control units and also for transmission control units. Okay, so WinOLS is something that I use every day and is a very big part of the reverse engineering process. A lot of people as well will use something like Microsoft Visual Studio or Visual Studio Code with the high-tech IDE compiler, which allows people to essentially compile C++ into Tricore assembly language, okay? And then they can inject their code that way. For us, we're going to be doing it with Ghidra. Ghidra essentially is a tool developed by the National Security Agency in the United States, and it is it's called a JRE or SRE, which is basically it comes down to a reverse engineering environment or a decompiler, which allows us to convert the hexadecimal code that we see in a binary file into code that we understand, or functions and logic which we can understand at a little bit of a higher level than machine language, which will give us our, like I said, it's called assembly language, okay? And every different processor will have a different language that they have in assembly. With Tricore ECUs and Infineon, they have a Tricore standard, a Tricore language for assembly, and essentially that's what we're going to be working with today. So my job essentially, we've got our defined file on the right hand side. I have already taken the liberty and time to import these files into Ghidra. On the left hand side we have the 488 pista that we're working with, and on the right hand side we have, like I said, the definition file, which has all the variables and everything that we need. So I have to find where they match between them, essentially find the logic that is similar between them, and then basically transfer the definitions across labels and all those sorts of things, so that I can begin identifying the code regions and the parts of the code that I want to start manipulating. So the first thing I'm trying to do here is come up with a possible list of engine speed variables that are sent over the CAN bus to the cluster, and the cluster obviously is the tacho in front of you, so that is used to indicate the current vehicle speed, engine speed and temperatures and all those sorts of things. So what I'm trying to do is hook into the engine speed variable that goes on the CAN and indicate the current selected map. So it's all going to be used for multi-mapping and map switching and all those sorts of things, okay? Cool beans. So let's get straight into it. We've already defined one of the engine speed variables. However, I've already tested this, and unfortunately this had no effect. So for me, I'm probably going to go through WinOLS, and I've got, like I said, the defined file on the right hand side as well, and my particular bench file for the 488 on the left hand side. And I've typed in the search bar 1-min, which is essentially the unit type for engine speed when it comes to Bosch. You can see here we've got 1/min. So I'm going through all these different variables, trying to find a likely variable that is sent out on the CAN, and we'll see how we go with this. So going through all the different variables, trying to find something relating to communications or CAN bus. Often there are different engine speed variables used for different purposes. What happens obviously is that there will be a read from the crankshaft and the camshaft position sensors to try and get the overall idea of what the engine speed is. But then there are different variables that come from that and stem from that, which are used in different functions. So there might be an engine speed idle control variable, there might be an engine speed variable for the load, an engine speed variable that is a 16-bit, an 8-bit variable, it might even be a word, all these sorts of things. So the ECU is constantly splitting the engine speed into different other sub-variables that are used for other calculations, right? And that might be because it needs a different resolution, like I said, 16 or 8-bit, and there also are different I suppose, how do I say it, like other different types of variables that are used for the CAN bus. So I'm going through all of the different engine speed variables that are defined and trying to find something that might be used for the cluster. And that's pretty much what this looks like. So for me, I might see something like this, right? It just says engine speed. My job will be to copy the variable ID, go into where it's defined, and try and figure out what function it's used in. So ASAP2 demo allows me to go through the definition file of a particular engine control unit and a software variant and see how the entire logic system, I suppose, is interconnected between the measurements, characteristics, and the functions. So if I go right click on the variable name, and it gives me referencing functions, and you can see here that we have a module called the transmitted messages of the ECU. And we also have a frame manager application standard. So I would say that it's very likely that this particular engine speed variable is used on the CAN bus, because you can see it's transmitted messages of the ECU. So I'm going to go ahead, copy this, and we're going to go into our function sheets and try and find an example of the logic that's used with this. I probably have to download the function sheet because a lot of the stuff is on a drive. So once this downloads, I'll be able to go through the module where that particular variable is used and see how the logic is all interconnected and see whether or not it is a likely variable for the engine speed that's sent over the CAN to the cluster. So it's a big process, and there's a lot of, I suppose, information, files, and different bits of data that you need to get an overall idea about how to manipulate and adjust program code. And it takes a lot of time, if I'm honest with you. There are other ways which, let's say, if I didn't have access to these particular things, or I didn't have these particular things for my own education, you'd need to spend time essentially going through all of the different references in the file that are related to engine speed. So if I give you an example of that now, if I go into engine speed here, that's derived from some other RAM variable, right? I've already defined this. But if I was to go here, we can see EPM and eng on the right-hand side. So that is what it is on the left-hand side as well. There is many, many different things. You can see here, we've got references here. We've got 208 references, of which, let's say 205 of them are a read reference, or 202 of them. And you can see here that data is loaded from that RAM variable, and then it's stored in something else. So I would have to go through every single iteration of these 208 read operations for this particular RAM variable, and I would have to go and individually basically force the variable value to 0, write it into the ECU, see whether or not it affects the cluster, and if it does, then you know, I suppose that tells you that that's the cluster variable, we've got the right one, but that process takes a very, very long time. Okay, so if we're going to go into here, I'm going to go ahead and have a look at the function variable that we need. So it's this one here, and let's see if it is defined in this. So if I go engine ECU co, let me have a look and see if I can find that function name in here. Let's have a look. Engine ECU co, transmitted messages of the ECU. So if I go ahead and search for this in here and see if it gives us anything. So it just tells us engine speed. I don't know if it's going to give us any more different examples of references to this. Probably not. All right, what we might do, we might go back, try and understand a little bit more about what this function's about. So we go right up to the top. Let's have a look here. engine ECU code, transmitted messages. So in this function, can variables are prepared and transmitted. So I would say we're in the right area, right? Assuming that we can say that the variables are sent over the CAN. It is indeed the CAN, right? So if we go through here, and let's try and find something that we might need. Different Class C networks. Let's have a look at this. F1 gearbox, dual clutch transmission. So these are all the different modules which are communicating on the CAN. Let's see if there's anything here relating to the engine control unit with the, let's have a look, body control, body computer. So NBC, that might be what we're looking at as NBC. We've got here motor gear, IMO code request, max engine torque, engine speed valid data, engine speed. So we've got here is an engine speed variable. That might be something I will have a look at. So if I go into my definition, I then go to, I know it's Q1, that's actually what I'm after there. If I copy that address, go to that address, look at the reference to this, and then I go to that in our WinOLS. That's that address, right? So the link between this particular address here, this is the hex code, so 8A02, 8A02, you see that? So I'm at the address in the binary file, which is the essential firmware or software of this ECU, of this software version. I've gone to the address where it's referencing that particular variable, it's storing a value to that particular address, and I'm searching for similarities between the two. So if I look for, let's say, a bit of code in the left-hand file, then we should be able to assume reasonably that it is the same instruction, and therefore we can assume it's the same operation onto the same RAM variable. Okay, so it just takes pretty much a little bit of what I'm doing here. I'm selecting a region of code and I'm trying to find similarities on the left-hand side, which I believe to be that exact bit of code. And this can be quite intensive. This can take a long time, and sometimes it might not take a long time. You'll see in a few other videos where there are very, very similar software versions. You might have code which is almost identical on the left and right hand sides. Another thing I might want to do is I might want to go to just some generalized sort of operation here and see, like right here, right? So we've got a shifting, and we've got an adding operation and a max operation. I'm assuming that that'll be the same between the two software versions. If it's not, then it might be likely that this particular variable isn't used in this software version, or it might be used in a completely different way. So that's something we have to be very careful of. I might go to a different variable and see if that might be something that we can reference here. Let's have a look and see, maybe this will get us what we need, right? Let's have a look. I don't know if it will, but we'll try our hardest. Let's see. I'm sure that operation will be pretty much the same. Okay. You see here that particular line of bytes is the same between the two software versions, but there's no other code that really matches. And if you have a look at where it is in the code, it's a different location, so I don't think that's going to be good for us. So these are one of the things that we're going to have to go through and try and find idle reference speed. Maybe we can find an example of where this variable might be used elsewhere, or some other variables that might give us what we're after. Gas pedal position. So we've got here FRM SB engine speed valid. I'm guessing, so that's telling us whether or not the engine speed we're referencing is indeed valid. Let's see if we go to that address here and try and find some similarities between the two files. Let's have a look. Nope, nothing there. It seems that maybe the CAN structure is different between these two. Maybe the operations in terms of the logic behind how CAN messages are transmitted and sent is different between these two software versions. So these are all things that I have to go through and try and figure out why that may be the case, right? Throttle errors. Engine speed error, EPM and eng. So we can see that it's derived from EPM and eng, right? We've already got that defined here, right? So we've already got that defined. So I'm actually gonna. So we know that one of these references is likely to be writing to that variable depending on this here. So if we can find this variable, maybe we can find this particular logic system in the file. So let's go ahead and try and do that. Let's go to this address, bit mask of 1. Okay, so bit mask of 1. Let's have a look and see what that is. Bit mask of 1 is a bit position 0. If you've watched my other videos, you would know that I've taught that a few times. Let's try and see if this variable is the same between the two. Okay, let's go to 100 and start there. Okay, that's getting close. That's getting close. See how there's green between the two files? That tells us that it's a matching in that code area. I'm just going to go and go through the remainder of the matches and see if there's something that may look a little bit closer. Because often there'll be, yeah, see again, right? Look at that. That's close as well, 46. Going through, I think, to be honest with you guys, 90, was it 92 or something? That seemed to be the best one there. Let's try that. Let's try that. So 22589E. 8022589E. Alright, so let's just have a look and see what's going on here. It's an equates, LEA, and the variable we're after is right here. Assuming that it's the same, but it doesn't look like it is. The reason why, I've highlighted where that variable is used, and it looks like it isn't used in the same way, or at least in the same amount of referencing. So I might come to something like this operation here and see if that is similar between the two. So even that, not really. This is where it gets really, really difficult to try and find certain things. I'm assuming if I can't find some examples of where we need to use these things, then we're going to have to look at going through each of the different references and trying to find something that is likely to be the engine speed to the cluster. I'm just going and looking at a few of these because I remember from before. I don't know if it's going to give us that. No, it's not. Let's go back into here. 1min. What was it? Engine speed. Let's have a look. Engine speed. And mots, they're all fine. I know that that's not what we're after though. This was the engine speed gradient. No, doubt it. What other module was this referenced in? I remember there was 2. Okay, FRM Apple standard. Let's see if we can find anything in this. FRM Apple standard. Okay, let's see if there's anything in here that we might be able to use instead. Validation of engine speed, that's all fine. We actually just need the engine speed. So we've got some checksum, message counter. So this is still CAN. That's good. CAN, yep, cool. So we're definitely in CAN. Engine speed, yeah, we've got the 2 variables here that we still weren't able to find. So we're going to try and find them. Engine status, gearbox type, status, all this stuff. So there's so much information that's sent over the CAN bus, right? So interesting. So if I can find the CAN structure of the file on the right hand side, I should be able to find it in the left. Looking through all of this, eh? And I just want to make sure maybe I'm... Okay, the EEPROM, we don't need the EEPROM. That's fine, all good. going through this, trying to find some more references or information about the engine speed. There is a lot to filter through, but it makes it worth it, because when you work through this and you sort of problem solve. Now we're in a different function, as you can see. Lin, that's another thing. It could be Lin bus. Let's have a look. See if it's in. What else do we have in Lin? Do we have a definition of all the variables in Lin? I don't remember it being in Lin. Here we go. No. This looks like all to do with the diagnostic trouble code handling. Here we go. There's some more things here. So battery, current, temperature failure, that's all sent over Lin. Okay, so we can reasonably assume that the engine speed sent over CAN, not Lin. That's good. Okay. What we might end up having to do is trying to find a module where there are some maps and sort of work with the maps backwards. It gets pretty hard. FRM Apple standard. Let's have a look. CD. FRM Apple standard. There we go. Okay. So let's see if this function, this module is actually in the software version on the left-hand side. That's another thing. Because if it's not there, that's going to make it a lot harder for us. So I'm searching for similarities between the left and right-hand side. If it's not there, that's okay. We can look at something else. We can try one of the other modules. Engine ECU code. See if that exists in here. There we go. Okay, so there's quite a few different maps here. Torque limitation for predicted torque. That must exist in this software version. It absolutely has to. I would say that those three maps there would probably be what we're after, but I'm just going to make sure by searching for that in the right side. That seems to be the only place. Let's see. That seems about right. So there is some maps here, which is exactly what we're after, right? There's three of the torque limitation for predicted torque, and these are what I can see only used in one module, and that's the module that's used for the transmission of messages. So what we're going to do is we're going to look for the relationship of this map to the measurement variables or the RAM variables. Then we're going to try and find it that way, because I know that this map exists in both software versions. Therefore, the RAM variables should exist in both software versions, and it should be pretty easy to find that way. So instead of looking directly for the engine speed variable, we're looking for a variable relating to a torque limitation map that is used between the two software versions. We should be able to look in the same data area, and there should be a read of the engine speed variable that the CAN bus one is derived from. And then we can go ahead, define that, manipulate it, test it, and see if that will work for what we need. Again, this might not even work. This might not even be anything relating to the cluster. This could be an engine speed variable that's sent to the fuel pump controller or something like that. The only way we can do this is by doing small testing, and the safest way to do that is just set the engine speed variable to 0, so that either the car won't start if it's going to an essential module, or B, it will just show you the cluster at 0, so when you're driving and when you're at idle, it'll just be sitting at 0, and that's essentially what we're looking for. So again, eng ECU underscore co. If I go down, eng ECU underscore co. All right, we're going to search for this. Here we have the logic system. We've got the input variables and the output variables. This is exactly what we're after. So I'm looking for this com variable here. We're going to find out what address it's at. Expected AK, and it's right there. So I'm going to go to that address in Ghidra. We can see there's quite a few references. That's pretty good for us, right? That's pretty good. I'm not going to complain about that whatsoever. I'm going to try and go to maybe a bit more predictable. There we. I'll try this. I'll try there. I'll try. We go to that. Let's go between these two. Boom. Okay, there's quite a few similarities, it seems. Let's have a look. Again, searching for code similarities in this particular function. There might not be any. Again, it's just this is all a part of the process. It takes a long time, a very, very long time. And obviously I'm just selecting random bits of code, but it would be wise to select things that are like simple like that, which is a multiply operation, and try and find similarities with that there. Just that's kind of close. It's kind of close. What else we got? A46C D9. It just doesn't look that promising to me, honestly. Like, it doesn't. There's not a lot of the code isn't the same between the left and right hand side. So maybe we should try a different reference to this variable here. Data. Let's have a look. Might this work for us? Let's try here. This all looks like pretty simple code that might be the same between the two software versions. Okay, we have something there. Let's try here. And there you go as well. If you have a look, you've got 07C as the address, and over here we've got 07F. So that could work for us. Let's have a look. 7F9A4. Okay, that's 7F9A4. Okay. So we've got this is being matching here. Oh, very, very close. That is a good potential for us. Very, very good potential example of what we're after. How many more is there? There's quite a few, hey? Ooh, I'm gonna actually just set that to a maybe. Right, so we're gonna go. Another thing, we can look at how many references there are to it. There's 17 and there's 32 here. Don't know, maybe. Look, there's 11 there, 15 there, 2, 2, 2, 3, 2, 9, 1, 4, 2. It doesn't really, maybe, look, I'll do it as a maybe. So I'll put that in, maybe, RAM, maybe. Cool, so that's one example of where it could be. Maybe we should have a look at some other examples. Finding this one might also be good for us. We've got a switch statement here. Okay, let's have a look at this. 9424, 9424, 9424, not the same. It's, again, just highlighting more regions of code to see if there are any similarities. Doesn't look like it at the moment, which is quite annoying. You know, you just want to get something done and you're just held back. All right, let's try this operation here and see if we can find something out of this. Again, not really, hey. All right. Let's try another variable in this particular bit of logic here and see if we can find it. There we go. Let's try and find this variable instead. Right. So, let's see. Okay, that could be good for us. By the way, guys, you're welcome to use the chat anytime to try and find out some things if you have any questions. 225 EDE 80225 EDE function 8. Oh, that could be good for us. doesn't look like that's it either. Pretty complicated little system here. Let's have a look. Are there any more examples of maps maybe that we can find in this area? Let's have a look. Some other maps that might be easier for us. Okay, that's definitely a match. Definitely a match. So let's have a look at where this map is in the logic. I've just selected the whole PDF. I do that sometimes. Like I'm still clicked in the PDF and I press Control A, and it's now going to try and select the whole bloody PDF. There we go. Okay, all good. Let's see if we can find this. Okay, so this one here. Surely this will be the same between the two. Oh, no, that's not what I wanted. That's what I wanted. Okay, let's see this one. All right. Let's see if this can give us anything similar. Oh, finally. You know, it takes so long sometimes to find this stuff. Jesus, I don't even know how long we've been going for, and it's like finally we found a match between the two. It's just obscene how long things take sometimes. 7B2 58 8007B 258. Okay, we're getting somewhere at very, very slow, like exceptionally slow. RAM, cool. All right, 4WD4. Okay, I'm just going to define all these and save where they are in terms of bookmarking. Oh. All right. PVD, that's probably a good one to have too, to be honest. Usually that's pressure in front of the throttle. Just some of these are just good to have in general, to be honest. PU, PW up here. That's a good one to have. RAM. We're just copying across all of the variables and defining them in the left and right hand sides. Okay. Okay, so that's one. Now we have TANS as well, which is intake air temperature. I'm going to try and find this variable here. Okay, read. Let's see if we can find this one as well. See if we're lucky enough to find this one. I don't know if we will be. A lot of guesswork going on here, trying to find different references to the intake air temperature RAM variable. Taking a while. I might go to a different reference of it. We've got engine temp in this one as well, as you can see here, TMOT's engine temp. So I'm going to try and find that. And we've got B Sport, which is sport mode. So we'll try and find this one. This one might be a bit helpful for us as well. But the thing is we need some code which is quite repeatable and predictable. So you have to go to some operations which are quite simple. And that's where we can go to FO. FO, let's try that whole thing. Okay, that was close. That was really close. There we go. I think that's it. I think that's exactly what we need. 66264 800 66264. Is that the correct one I am after? And that is, should be matching 12A there. Okay, so that means that if this is exactly the same, which it looks like it should be, that'll be B Sport. That's a good one to have, honestly. That's sport mode. Very, very good to have. Engine temp is this one there. RAM, engine temp, and then TARMS is this one here. That's intake air temperature. Okay, I think that's pretty good. I might just see, okay, so that is a, okay, B Sport. Then VMN unknown. That's bitmask unknown because I know it's, yeah. Anyway, it doesn't matter. So we've got TANs, we've got engine temp. What else have we got in the logic here? So we've tried to find this, couldn't find it, couldn't find that. Maybe if we can find something like this one as well, it'll be all in the same area. So that'll be good for us to find, right? Let's go to this address here. Go to a reference. Let's see, that might be the same between the two software versions. Let's have a look. Doesn't seem like it, does it? It's really good when you get a match. It feels great to see the left and right hand sides light up the same color. I don't know. Sounds a bit crazy, doesn't it? Okay. Here is an operation which is similar between the two. It's only 6 bytes long though. No, doesn't look like that's going to work for us. This might. Okay, that's similar. So if we go 166.892, 801.66892. So that's down there. Very, very similar. Very similar here. Very similar. What's the overall gist of this? Let's see if we've got our... Got a few variables here that we've seen before. I might go right up to the top and see if it's sort of like a similar start. Even the function call might be similar. Okay. So maybe if we go right back to here, right? Like, look at all this. This is pretty simple code, but it's not being used in the same way, which is just surprising, if I'm honest. Let's have a look at more of the logic. So we've got faux W, we've got TANs. Maybe if we can find something like this. This is the process. It's going through all of the different variables, trying to find where they connect. I don't need to do that there, sorry, there. Read. Okay, and just seeing maybe if we can find where match in these two. 1, 2, 1, 2, 3, 4. Not a match there. That's very annoying. Not there either. Not there either. There's faux and there's tan, so that's, you know, I might have to go through all the different. Let's have a look. Faux 20. Oh, I'll just go through all the 20 references and see where they're both in the same area. Really, that's engine temp. Okay, we've got something. They're the wrong way around, but I'm just going to go, I don't know, ref, faux TANs. Is it faux W or is it What is it? It is faux W. Okay, that's annoying. I might delete that then. Faux tens. Delete that. Faux W. That's got 32. Okay, so we're looking for tens as well. So I'm going to highlight tens so that when it comes up, we can see it. There it is. There's 1. 2. Interesting. We've also defined that there. So that could be it. I think that's it there. The one we had with the... There we go. I think that's pretty much spot on. I'm gonna say it is. It's a little bit of a different structure. So that variable there is that one there that I said was maybe. Tans is there, tans is there. Faux W is there, faux W is there. Alright. It's a little bit different, but I'm gonna go ahead and reasonably assume that the start of this function, which is quite big, and the start of this function, which is huge, really, look at that, that's massive, is probably going to be surely that can't be the start. That's massive. I mean, it could be. I'm going to go back to here. I'm going to go ref tens faux W. Now I'm going to look for EPM and eng because that's also in this. Also in here. I've seen it from memory. It's definitely in this module somewhere. I think we're definitely there. We just got to look for the... Has to be because that's oh, okay, so that's the engine speed. The com and sync. Okay, so that, let's see where that's used. XPT. Where is that used in this function? I've just gone and selected the whole thing again. Go ahead and use the chat, by the way, if you feel like you want to ask any questions. So if you have any questions, oh yeah, how do you get the logic? The logic's, yeah, I can't really say that, but if you need something, just reach out to me on Instagram or something. I'm assuming you're talking about this. Yeah, I can help you with certain things if you need. So there's a comment sync, EXPT, EXPT. So it's there. Where else have we got it? 26. So it's only used there. So that's good. So we're definitely in the right place. It's calling some, I guess, passing function. If we have a look here, remember there's three of these functions. What is the spacing between these two? Let's have a look. If we go spacing, so if I go 3, oh, actually don't even need to do that. F86, take F54. Spacing of 32. What's the spacing? That's not 32 between them. 38 to 6E might be. No, so it'd be loading to A4. 6E plus 32. Let's have a look. Plus 6E. AO. which is there. AO plus 3 to D2. Boom. Okay, that's it there. That's it. Okay, you're probably going, what the hell does that mean? Well, I'm actually, that's these three addresses. So this first one, so that's actually the first one there. So that's that 0 at, really it's 809 with the offset. Boom. Okay. This one is number 21, sorry. That's 54286. Okay, and this is number 3 there. 862B8. That's number 2. Boom. Just like that. That's a very, very helpful. So if I go reference 0. Okay, cool. A4 takes the value of the starting address of the map, usually the size, and then we have the variable that is compared against the axes. It goes through some parsing function, which I haven't got defined, that's fine. And then the resultant is usually in D2 from my experience. And then that gets multiplied with something, which would make sense because we've got tans and we've got faux up here. So that would be multiplied against the output of this map here, which is this operation, which means D2 should actually get stored in, see, I don't know what's going on there. It should actually get stored in here. So I'm wondering if I go right back and see D2, it should really be getting stored. I'm assuming that there, which is that there, is here. Okay. That's what I'm assuming. I think that's correct. That makes a lot of sense. The offsets between the different maps is true, and it's using the same variables, tans and faux. We've got the engine speed variable here, and if I look at what writes to that, I'm actually going to go and find out what does write to that. Let's see. Right, D0 comes from this, which is interesting. It's not something I'm familiar with. Same operations, that has to be that variable there, RAM. Boom. What does that get written by? It doesn't tell me. Fair enough. Okay. I'm gonna say that's not a maybe then. That's definitely what it is. I'm gonna go there and RAM. Save that. Cool. Do we have any no other questions? All good. Let's have a look. All right, keep going through. We know we're in the right place. So in here should be the variable that we're looking for. Again, if I go right back to the function, then we're looking for that engine speed variable, aren't we? Which is, it was 1/min. I remember that in RAM. No, that's not it. That's the one there. So that's what we're looking for. And that does operate with that there. So I'm sure we can find it somewhere. I'm going to go up through this module and see if we can find that. There should be some reference to it somewhere. Let's see. I'm just going to go back. EPM and eng. Might even try and do this one too while we're at it. If I got cruise control ST in here, ST key, I do have it. Shit. References. Where it's at the start of a function. Okay, that's not helping us at all. EPM and eng. Let's go back to this. 116 references. This is going to suck. Okay. Going back down. Because it's writing D2. D2. Okay, let's have a look. Let's go through all of this. It's a load high into D4. Let's have a look if I go through D. Load high D4. If I go through all of these, and then I try and find the D2. There's a D2 there. D2 there. There's quite a few actually. Maybe if I go through these and just have a look and see what looks to be the most similar around the sort of operations. There's a shift just before it. Very hard. Very, very hard. How many references are there to this function? 1. Oh, that's another function there. Is that the same between the two? Let's have a look as well at that. Grasping at straws here. Function. Function. What about this here? Yep, that's, thank goodness, 1A198D. 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 And that's 26F. 26F. Somewhere around here. So that looks to be the same there. We've got the same end of function. And we've got that there. That's good. But then, okay, here we go. Function, 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 function. Okay. Is that part of this, is it? Is that what I went up to the top of? I don't know how I got to there, if I'm honest with you. That's really annoying. I was trying to find... Oh, that's right. That's what I was trying to do. Find the reference to that. That makes sense. That's why I was so damn confused. Oh, it's not even... Okay, hold on. Okay, ref... obviously function or module, not function. Call near eng, pull or from eng can. Okay, so I think what I need to, you can see how I've got a reference. I need to find where the reference is for this, because I'm guessing that there is that there. That would make the most sense. So I need to define more of this file. So if I go back through it, and then let's say I need to define, I'm guessing there's code in here that's not defined yet, so that's the thing. Okay, if I disassemble, see if that's going to get us somewhere. Still no reference here. There has to be a reference somewhere. Just wondering, has something not been correctly... Is there something I'm missing? Or is it that this particular function let's have a look. Found that very interesting. I'm wondering if, because if it is dual ECU, which I think it is dual ECU, if maybe the other ECU has some values that aren't in this one. I'm looking at the general file size. Looks fine. This doesn't look like it's missing anything. Alright. Have we done the general purpose registers? They've been set, that's good. That's fine. I don't know why we wouldn't be getting a reference to it then. Super interesting. I might have to come back to it, eh? We'll see, because that is definitely the same as that. But the reference or the call from here, which is near that variable we need, is not really apparent, and it's around apparently this sort of area here. Just makes me think, like, what's around here there? It's like, let's see if this exists, this call or anything in any bit of this code is remotely similar. Try and find something. Might have to come back to it. Hey, we'll have a look. There's not really enough there to say, is there? 20 similarities. Not really enough. Big string. Nope. This is the process of finding things. All, like, what have we spent now? How long have we been online for? We've been online for an hour and 1 minute, and I'm still trying to find the reference to the engine speed variable on the can. That's how long sometimes this takes, and that's why I guess you pay a lot of money for this sort of thing. It's because of just the sheer amount of time and knowledge that's required to actually get to a result. You know, it looks cool on the face of everything, but all the work and effort behind it is just obscene. A lot goes into it. A lot goes into it. So, definitely not. Very difficult. End stat. Let's see if we can find this variable here. Function. So we'll look. That surely. That'll be the same for sure. Let's keep going through it all. Nope. Right. Let's have a look maybe here. No. Very few similarities. Incredible. I just thought there would have been way more. Way more. Gonna go back. Maybe go here. See if something like here is the same. Wow. Still nothing. I'm getting more and more of the belief that there is some part of this file that I am missing that may be in the other ECU. So I might have to come back to it, guys. I'll get back on the live stream once I know for sure, because I feel like I'm missing some code. The references shouldn't be this hard to find on the same engine. So yeah, anyway, I hope you've enjoyed where we're at. You're welcome to ask questions in the chat. If you do have any questions, we've been going now for just over an hour. Yeah, go ahead and ask them in the YouTube chat if you want. I can answer them to the best of my abilities, and try and help you. Otherwise, yeah, I hope you've enjoyed it. I'll give you guys about a minute. All right. All good. I think that's pretty much it then, eh? All right, I'll see you guys later. Thanks for watching.